Today I'm going to reveal one thing you should definitely add to your job spec to guarantee the integrity of your project and to maximize your ROI. Hello, I'm Pete Mitchell with the GMA Garnet Group. I'm the Vice President of Technical Management. So what we were going to talk about today is talking about the classifications of blasting and what a true clean surface is. There's standards in this industry that they set for near white, regular white metal, and it's always been curious to me why you can do a specification for a job and you can have 30, 40 page long specification and 30 pages of that, or 29 pages of that are to the actual coating, and there's this little snippet at the end about how to blast it. You read in any class that 80 to 85% of the failures on a coating job are due to improper surface prep. So in your guidelines, they give you the standard SP10, or which is NACE 2 near white, and you got your SP5, which is your white metal. That's not a get out of jail free card there. That is a standard, but that's a guide. That does not set. Just because an inspector walked in the door and said, yep, that looks like white metal, you can't say, oh, my surface is perfect and that's exactly what I need for putting the coating on. What we've done is we've gone in and done some further research into the blasting. We've done some magnification pictures here. And what you have is, this is a true white metal. This is a surface that was blasted with our Tough Blast. And it looks spotless. I went in and did some further investigation. That surface right there actually has about 3 to 4% embedment. Every surface, every abrasive leaves something on the surface, but not much. But what's really critical is when you start looking at some of the other abrasives on the market, you start seeing two different things. You see actual embedment. You see angular crystals or very, very friable crystals that tend to shatter and they embed into the surface. They stick into the metal. You'll also see some that almost look like they splattered onto the surface. It looks like you shot a paintball at the steel surface, and it cakes on the metal like a clay. Some of these you can see contaminant. I've seen contaminant as high as 50, 60% on the surface, but with the naked eye, you looked at the plate and you said, it has a little bit of a shade to it, but yeah, that's white metal. Well, 50% of a surface being covered with an embedment is not white metal. And it's not just one particular product or a few different types of product. You see it in both your byproducts, your slags, your glass, anything that was a derivative from another product, or you even see it in your natural minerals. In your byproducts, like your slags, very angular, but they do tend to shatter, and that's where you get heavy embedment. You see, it's almost like knives thrown into the steel. And I've seen on average about 40% of the surface is covered in embedment. Some of the other slags tend to have some miscellaneous byproducts in the material as well, and that's where you see the caking. The particular one in the middle there is actually a green blast abrasive, but you see the white and blue spots on it, and I'll show you a slide in a minute and show you actually what that is, but that was a byproduct in there that was caked on. Here we're looking at 3 natural abrasives, and usually these particular products, you would look at it and say this is your go-to for white metal, but look at the actual surface. That picture is just 25 times, and so it looks like there's paint on the surface. It almost looks like somebody splattered paint. Well, what that is when you have natural minerals coming out of the ground, there's other byproducts in it. If I'm gonna sell garnet, I wanna put as close to 100% garnet in the bag as I can. Other natural softer minerals tend to hit the surface and cake and cause this contamination. When you look at byproducts, slags, you have one there on the left is a coal slag. You see the chunks actually in the surface. Well, where you try to read a profile on that misleads you on what your profile is because it's sticking out, but 2, that's what you're trying to get the coating to stick to. The one on the right is actually a nickel slag. And then remember a minute ago I was talking about the blue and white spots. That material in your hand looks like it's green. It's just a natural, it looks like a green sand. but on the surface it leaves those little white and blue caked areas. And I wondered what it came from until I zoomed in and took a magnification. I took a 25 times picture of the actual mineral, and I see the other trash mineral or trash particles that are in there that cake to the surface. All of that is going to impede getting your coating adhesion and going to cause problems down the line. We then took it to another level and did backscatter microscope pictures, and you see the top, which is one of the other garnets, and you see a few spots. The yellow is the actual steel, and then you see the blue, the greens. It's interesting when they do this, they can even tell what mineral it is by the scan that they take. The one on the bottom had 40% embedment, and again, when the inspector looked at it, he said it's white metal. Remember, the definition for white metal says no contaminants. The definition for near white says no more than 5%. Well, if you're 40% embedded on the surface, you're not even near white. Here's another interesting one, that this particular product is one of its marketing tools is that it cleans the surface so clean, the steel sparkles. Well, anybody that's really looked in with a magnified picture of a good blasted white metal clean surface, metal doesn't sparkle like that. So there has to be something else on there. So I went and did 25 times and 75 times pictures of it, and it's obvious to see what the issue is. It is actually left a cake. It looks like some of it's embedded, some of it looks like it's actually physically caked on there on the surface, and the sunlight is catching it and making it sparkle. So instead of saying that it's that clean, you've actually put a film on the surface that the coating is not going to be able to get to the metal. Here is a comparison. This is Tough Blast. This is our Tough Blast product, and one's 25 times, one's 75 times. Look at the difference in the white metal, in the nice clean white metal. You don't see all the other contaminant on there. Here's the two side by side. So I then took it down and did the backscatter analysis of it. You can see the different portion on there, and it specifies that it's calcium silicate. This particular material is an abrasive that's made with tempered glass, and having calcium silicate on the surface just made sense. It's the contaminant from the abrasive. An interesting twist that we took from this when we were really looking at the embedment level is I took a device that does a 3D peak density test, because I was curious why some that looked with heavy embedment on it, I noticed that your pull test, your embedment, your adhesion levels, like your TSAs, your high temp coatings, that the adhesion is critical. We noticed that some would have very strong pulls and some would have very light pulls. And we're trying to figure out, well, why, when they have the exact same profile, is the pull different? Well, we went in and noticed the peak densities, and one product had up to 24,000 peaks, the other only has 6,000. Well, then when you go back and look at the magnified picture of that, the product on the right that only has the 6,000, all those red peaks, that's also the same one that had the embedment. So it leads to believe that what you're reading those top of the embedment. So realistically, that abrasive only gave you maybe a 1.5 mil. Let's say you were getting a 3.5 mil with Test-X tape. You're only getting you really only have a 1.5 mil, and you wonder why your coating's not sticking to the substrate. Wrapping this up, you have your specifications. You have your SSBC SB10, you have your SB5. Even by definition, you see near white blast says there should be no more than 5%. But then you go down to the acceptable variations, and they offer you variations of shading and discoloring, and it lists the blast abrasives. But again, it says it must meet up top to be less than 5%. You go to white metal, and it says it should be clean. So it does lead to wonder, both of those say by the naked eye, but if you look at one surface next to each other, and one is a nice clean gray surface and one has a brown tinge to it, or one has a green tinge to it, you can't say that's a minor shade. Realistically, if there's 40, 50% embedment on the surface, that's not white metal. So with all of that information, what that tells you is you can't just put into your spec surface must be SB5, surface must be SB10. If you're a facility owner, if you're a coating manufacturer that's putting a warranty on your product, if you're someone out there that the actual final outcome of that asset is critical to your role, you need to go further than just throwing a okay spec to get by the job. You need to look further into it and see, is that surface truly clean, good white metal? So when you're writing a spec, when you're putting together the scope and the plan, this is where you should look into speccing abrasives that do not change the surface, that do give you true white metal and give you the outcome that you would want.